Now that we know what state is, and now that we also understand how we can listen to events, we can continue working on this application and turn this more and more into an expense tracker. And one important piece is missing, for example, well, the capability to gather user input so that users can add their own expenses. This sounds fairly important for an expense tracker, and up to this point, it's not possible. So that's what we'll work on next. And for that, I will first of all add new components. And I'll add a new category of components, you could say, because thus far the expense components we have here are about outputting expenses, about showing these expenses here. Now I want to gather user input. And therefore, I'll add a new subfolder in the components folder, and I'll simply name it new expense, because ultimately that will be what the components here are about gathering the input for a new expense. And therefore in here we can add a new expense.js file, which will hold the new expense component in the end. And inside of this new expense component, I want to render a form where users can enter their expense data. So here I'll add the new expense const, where we have our component function. And of course, I export new expense here to make it available. And we can import React from React. As I mentioned, you technically don't need to add it. I covered this in the last course section, but I will still add it here since you will see that in many React projects. And I want to again make it clear that JSX under the hood uses this React library. Now, as I mentioned, the goal with this component is to return a form in the end, a form for our inputs. And I also want to provide some styling around that form. So I'll first of all return a div, and then inside of that div return a form. Now, speaking of styling, we can also add a new expense.css file, and you find that file attached. You can either just paste in the styles you find there, or simply replace your new expense CSS file with mine. And then, of course, make sure you import new expense CSS. And that's all something you learned about in the last course section. That's all not directly related to state or user input, of course, but we'll get there. So now that we got this imported, let's add the new expense CSS class to this div. And let's now work on the form. And actually, I'll take that form and put it into a separate component, just so that the form logic lives in its own component. And this component is really lean again. Not something you have to do, but something I will do here. And I did talk about splitting components in the last course section as well. So we can add an expense form.js file, and in there create an expense form component function like this, and then of course also export that function expense form like this. And if you want, import React from React, even though it's not technically required. And I'll also set up some styles. So I'll add an expense form CSS file, and you also find that file attached, and you can replace yours with it. And then, just as we saw it multiple times, import that CSS file, the expense form CSS file. And now here in the expense form component, I will return this form element, and in there we'll then structure this form. Now, when it comes to structuring the form, for gathering expense data, I want to let users enter a title. I want to let them enter a date or pick a date with a date picker. And of course, users should be able to enter the amount. So we'll need 3 input fields. And for styling reasons, I'll put every input field in a div, where the div has a class of new-expense __ controls. Or to be precise, that's actually a div which will hold all inputs. But then I'll create another div in there with a class of new-expense __ control for a single input. And in there, we can now set up a label, for example, title for the first input, and then add an input of type text like this. as a self-closing tag here in React because these input elements don't have any content between the opening and closing tags. So we can and should write it as a self-closing tag in React. Now that's how we can create a first input here. And of course, these are all just default HTML elements, nothing React specific here. But we're soon going to add listeners to wait for user input, and we're soon going to manage some state with that. So this is some crucial groundwork which we have to do first. Now we can copy this div with the label and title and duplicate it to also have an input for the amount. The type here could be number, and we could set a minimum value of 0.01 and set up a step of 0.01 as well. And these are just default HTML attributes for input elements, which control how this element can be used. And last but not least, I'll replicate the div one more time to also provide an input for the date. Set the type here to date, and this will then automatically give us a date picker. And I will also set up a min date and set this to January the 1st in 2019 and add a max date, which I'll set to 2022 and there December 31st. And I'm picking this min and max date because later we also want to add a filter where we only provide the years 2019 to 2022 for filtering. So I want to make sure that these are also the only years expenses can be set to. Of course, you can play around with these values. These are just some example values I'm working with here. Now we got all these inputs. We now also need a button to submit the form. And therefore, right before the form closes, I'll add a new div next to the other div, which holds the controls. And in there, I'll add a new expense actions class like this, new dash expense underscore underscore actions. And then in there, add a button where we say add expense like this. And I'll set the type of this button to submit so that when this button is pressed, since it's inside of this form will be submitted. Now that was a lot of work on the expense form. Now we can use the expense form in the new expense component. And therefore we of course want to import our expense form functional component. So this component function, we import this from new expense.js without the file extension like this. And then here we can just render this and add it as a HTML element in our new expense function body. So that the new expense component will render the expense form component. That should be expense form, of course, my bad. So expense form is being rendered here. And now I want to render this entire new expense component in the app.js file. Because in there, in the end, we're combining all these components. So here I'll import new expense from /components/new expense/new expense. That's the path to this new expense JavaScript file. And then here, finally, instead of this dummy h2 tag, we can render new expense like this. If we now save this doesn't load because I have an error in the new expense JavaScript file. I'm importing expense form from new expense. That's of course not correct. I should be importing from expense form. That's where this component lives. Otherwise, I create an infinite loop, and that's this page. That's causing this page not to load. Now this works after changing this and restarting the server and revisiting localhost 3000. And now we have this form here at the top, which is great. Now we added the component, but the component is not doing anything. My next goal is now to make sure that we gather the inputs the user chooses here, maybe on every keystroke, or basically whenever the value in one of these inputs changes, so that we can, for example, log this to the console for a start. And that then as a next step, when the form is submitted, we step in our code and we take these gathered input values and combine them into a new expense object. So let's now work on gathering user input. And as I said, for a start, I want to react to every change in any of the inputs. So for example, on every keystroke, and I simply want to get the value the user entered and store that somewhere. And for example, just log it to the console. Now, to do that, for a start, we need to add listeners to listen for every keystroke or for every change of these inputs. And you learned that you can do that on the element where you want to add a listener. So for example, on this input here, by adding a prop that starts with on, and then the question just is to which event you want to listen. Now we could listen to on input and therefore react to basically every keystroke, but there also is the on change event, which basically does the same here. It will also trigger on every keystroke, but the advantage of the on change event is that we can, for example, use that same event for all input types, for example, also for dropdowns. So here I will add on change this event listener to this input or this prop to this input. And under the hood, this will then add an event listener for the change event to the input element, which is rendered in the DOM. And then we need to point at the code, at the function that should be executed when that event occurs. Now you learned that we can define it inline here with a function or with an arrow function, but that it's better to define it up front, and therefore that's what I'll do. I'll add a new const and name it title change handler to make it clear that this will be called upon an event. I end with handler, and I'll name it title change handler because this function, which I'll store here, should be executed whenever this, well, title input changes. So here, for the onChange prop, I'll pass a pointer at this title change handler, so at this function here, as a value. And again, we don't execute it here. We don't add parentheses. We just point at this function. And this, if I console log now, will now execute whenever we type in this title input field. So if we go back and open the developer tools, if I type here in the title, you see title changed for every keystroke I do. Now that's great, but typically we want to get the value the user entered. And the question now is, how can we get that value? Which possibilities do we have here? And the answer is quite trivial, at least if you know vanilla JavaScript, so JavaScript without React. If you would add an event listener to some element in vanilla JavaScript like this, then you would listen to, let's say, the click event, and in the function which you pass as a second argument, which by the way is basically the function you pass as a value to this prop, there you automatically get an event object which describes the event which occurred. That's a default JavaScript behavior you get in the browser when you listen to events. And we get this default event object here as well, automatically. We don't need to do anything to get this. Since we pass this function to React basically through this onChange prop, React will make sure, or actually even the browser itself will make sure, that we get such an event object when this change event occurs. Now we can log this object to see what's inside it. So I'll log this event argument, and if I now reload and I start typing, I get this object here. And this object has a bunch of data. The interesting thing for us is this target field here. This target here simply points at the DOM element for which the event occurred. So in this case, this input. And this input element in turn has a long list of properties which we can read and set. But most importantly for us, it also has a value property. And this value property holds the current value of this input at the point of time this event occurs. And that's super useful, because that means that we can drill into this target and then this value I just showed you to get the value which was currently entered when that event occurred for that element on which we're listening. So now if I reload, you see that I get the current value with every keystroke. And that's super useful. Now we got this value. The question now is, what do we want to do with that value? What's the goal now? And the answer is, well, we want to make sure that we store it somewhere so that when the form is submitted, we can use that value. Because of course we want to gather all values for all inputs and then combine them into an object when the form overall is submitted. And one way of storing that value and making sure that it survives, even if that function would be re-executed for whatever reason, so this component function, I mean, to make sure that we store the value and that it survives if that function would be re-executed and the component would be re-evaluated, we can again use state. So we can import the use state hook from React here and basically just call it here at the beginning of the expense form function and set the state for this input here, so to say. And initially that's an empty string because initially when this component is rendered for the first time, nothing was entered. But then we can again use destructuring to get our two elements, which is the currently entered title, maybe we name it entered title, and a function for updating the state, which, following the convention, should be named set entered title. And here, when we react to this event where the user enters something, we can just call set entered title and pass event target value, so the currently entered value, as a parameter, as an argument to set entered title. And therefore this will be stored in our state. Now here I'm not really doing it to update this component, though the component will update. That will always happen when you update the state. But I'm doing it to ensure that we're storing this in some variable which is kind of detached from the life cycle of this component function, so that no matter how often this component function might execute again, this state is stored and survives. There would be other ways of solving this as well, but that works just fine. And it has another advantage because we'll need that state for updating and for re-rendering that component later anyways. But for the moment, we just use it to save the value. Now we can do the same for the other two inputs, and of course definitely try this on your own as well. Pause the video and make sure you listen to these change events for the other inputs as well, and that you also store state for those changes. So here's your chance to pause the video. Thereafter, we'll implement this together. So, did you add that? Let's now do it together. And I'll start by adding a new function, and that will be the amount change handler. And the logic is basically the same as before. I want to make sure that this function gets triggered whenever the amount changes. So on the amount input, we can add a onChange prop and point at the amount change handler just like that. And before I add any code in there, I will already add the third function for my date change handler, like this, and that should be triggered whenever the date changed. So here I also listen to onChange and point at the date change handler. So now all these inputs are wired up, but of course at the moment nothing is happening here. Now I also of course want to store state for changes made here, and that brings up one important question. Maybe a problem you also encountered. How can you manage more than one state? It is something we haven't learned up to this point. But it turns out that it is rather simple. You can call use state more than once. Maybe you tried that, and if you did, good job, because you can do that. You can have multiple state slices or state pieces per component. And all these states inside of one and the same component will then also be totally separated from each other. So here I'll call use state again and extract my entered amount and my set entered amount function with array destructuring. And now we got these two pieces of state which belong to this component. And we can update and read them individually, so they work in a totally separated way. When I update the amount, this will not affect the title, and vice versa. So for the amount change handler, we can call setEnteredAmount and pass in event target value here as well. Well, and unsurprisingly, we can do the same for the date. Call useState again and store an empty string here as well. By the way, I'm storing strings all the time and not a number here for the amount, for example, because by default, whenever you listen to the change event for an input, if you read the value of that input element, it'll always be a string. Even if it stores a number, it will be a number as a string. And the same for the date. So we always get a string here. That's why I also initialize all states with a string. And here, therefore, for this third state, I have my entered date and set entered date. And I now also can update this state here with set entered date event target value like this. Okay, now we got these three state slices, and this is really important. This is absolutely okay, and you will see that quite a lot, that you have more than one state per component. You can have these separate states and update them separately and manage them separately. That is a key part of this entire state concept React ships with. You can and you often will have multiple states per component. Nonetheless, this multiple states versus one state thing is a concept I want to take a closer look at. So in the last lecture, we added these handler functions and we added multiple state slices. Now I did emphasize that you can have multiple such slices, that this is totally normal. However, there also is an alternative, and it depends basically on your personal preferences, which approach you prefer. You can have multiple slices, but you could also argue that of course all three states here are related to our form. That in all three states we just store some user input, and that it's therefore basically the same concept repeated 3 times. Therefore, you could also go for one state instead of 3 states. How? Simply by commenting this out, by calling useState only once, and by passing in an object as a value. And that's important, not a string or number or anything like that, but an object. And of course, in this object, you can now group together your 3 states. You could have a title key or maybe also an entered title key, and that holds an empty string initially. And you have an entered amount key as well with an empty string and an entered date. So the logic is kind of the same, but now it's in one state object managed as one piece of state instead of 3 separate slices. The difference now, of course, is that whenever you update this state, you need to update all 3 properties and not just one. So here you could then also extract this and have your user input, for example, and set user input. And now when the user enters a title, you wouldn't store it like this, but you would call set user input. And in the end here, you then want to pass in a new object where you set the entered title, in this case, to event.target.value, but and that's now the tricky part, where you also ensure that the other 2 pieces of data don't get lost. If you would just set your new user input state to this object, you would basically dump the other keys. Because when you update your state, React will not merge this with the old state. It will simply replace the old state with the new one. And if your new one is an object with 1 key value pair here, the old state will be replaced, and therefore the other 2 key value pairs for amount and date would be lost. So if you go for this one state approach and you manage such an object, it's also your responsibility to make sure that the other data does not get lost. And to do that, you manually need to copy the other values which you're not updating here. So if you are updating the title, you also want to copy in the existing values for amount and date. And one way of doing this would be to use the spread operator, which is a default JavaScript operator in modern JavaScript. And you copy in user input like this. Actually, you do this first. And then you just override entered title. If you haven't seen this syntax before, this in the end just takes an object, pulls out all the key value pairs, and adds them to this new object. And then we can still override key value pairs, like in this case, entered title. And by doing it like this, we ensure that the other values aren't thrown away, but are also part of that new state. And now we could do this in all three places here, of course, and update the entered amount here, and do the same here, just that here we update the entered date. And that would be an alternative to having the three individual state slices. It's up to you what you prefer, and this code also isn't perfect yet, by the way. I'll come back to this in a second, but generally you can switch between these approaches. Now, I tend to prefer the individual state slices, and I would say you also see that more often out there in the wild, in other React projects, but ultimately both approaches are fine. One thing is not fine though, and that is how I update my state here when I also consider my old state for copying in values. And that's something we're going to take a closer look at in the next lecture. So in the last lecture, I showed you how you can use one state instead of multiple states, and I did talk about it there. Now, the way I'm updating my state here is not entirely correct though. It technically would work, but in niche cases it could fail, and it's simply not a good practice to update it like this. So what's the problem here? Here, I'm depending on my previous state for updating the state. In this case, we depend on the previous state because we use this one state instead of three states approach, and we need to copy in the other values so that we don't lose them. Hence, we depend on the previous state snapshot to copy in the existing values and then just overwrite one value with a new one. Now, whenever, and that's another key rule which you should memorize, whenever you update state and you depend on the previous state, so for example, as we do here in this object, but also if you would be managing a counter which you increment by 1, for example, whenever you update your state and you depend on the previous state, you should not do it like this, but you should use an alternative form of this state updating function. Instead of calling it like this, you should call it and pass in a function to that function. So you call the setUserInput function and you pass a function to it. For example, such an anonymous arrow function. And this function, which you pass to setUserInput here, will automatically be executed by React, and it will receive the previous state snapshot for that state for which you're calling the updating function. So in this case, for this object state here. So we'll get the previous state snapshot, and now here we should return the new state snapshot. So instead of this function which we pass to the state updating function, we return the new state now. And that now could be, or in this case should be, our object, where I copy in the key value pairs from the previous state with the spread operator, but where we then also override, in this case here, entered title with event target.value. Now, why should we do it like this instead of like this? In many cases, both will work fine, but keep in mind that I mentioned that React schedules state updates. It doesn't perform them instantly. And therefore, theoretically, if you schedule a lot of state updates at the same time, you could be depending on an outdated or incorrect state snapshot if you use this approach. If you use this approach, React will guarantee that the state snapshot it gives you here in this inner function will always be the latest state snapshot, keeping all scheduled state updates in mind. So this is the safer way to ensure that you always operate on the latest state snapshot. So you should use this function syntax here whenever your state update depends on the previous state. That is something you should memorize. If your state update depends on the previous state, use this function form. With all of that though, I wanted to show this because these are key concepts, which you're also going to see again and again throughout the discourse and throughout a lot of React projects. But here, I will actually comment out all of these alternatives, and I will switch back to that multiple states approach instead, which we initially had. So let's comment out all of that and go back to this initial approach. I just wanted to show the alternative because it is a valid alternative. You will see it in many projects. You will have scenarios where you need it. And this thing regarding the if you depend on the previous state, use this approach thing here, that's something you should keep in mind in general, because you will often depend on a previous state, not just if you merged state like this, but also in other scenarios like the counter, which I mentioned, for example. So that's why I mentioned this. Nonetheless, let's go back to this multi-state approach now.